Okay, good morning. I hope everybody's doing well today. We're going to go ahead and get started here. We only have 3 students right now. Hopefully we'll get a few more in the next few minutes. I am going to talk about the exam a little bit. Unfortunately, I do have one student registered for this class that has not taken the exam because they weren't there. So I cannot talk publicly about individual questions related to the exam. Additionally, I teach other sections of Tech Math 204, and I have students in those classes that have not taken the midterm exam either. So I have to be careful talking about individual questions or problems. However, we will talk about the midterm exam a little bit, and most importantly, how you can pick up your personal exam, your the exam that you wrote over the next week or two. Okay. So first of all, let me share my screen here with you. You guys can find your grade, your marks for the midterm exam in the grade book. So in the grade book, in ideas. Okay, so in fact, you should be able to see everything in your grade book. Please note at this time, you should only be looking at the past due information in your grade book. I noticed that there is a past due and available or attempted. I can't remember which one it is. It's past due and available or past due and attempted. You should only be paying attention to the past due column in your grade book because the weighted average is your midterm grade in the course. And of course, in there, you should find your midterm exam grade. Now, of course, I do not have a grade book because I'm not a student, so I can't click on this. Well, I can, but it just gives me an invalid student ID notification. So you can look at your grade. It should be a number out of 32. It should be a number out of 32, so probably something like 26 out of 32 or 23 out of 22, or perhaps if you didn't score so well, you had like a 15 out of 32. And if you hover over the number, you should see a percentage. And of course, that is your percentage score for your midterm exam. Okay, so probably more importantly is how can you pick up your exam? Your exams are your property, not mine. And so at some point, I would hope that you would take an opportunity to come and pick up your exam. Now, in order to pick up your exam, you'll have to come to the North Humber campus. So this is all at the North Humber campus. There are a few available times. Now, unfortunately, I am not on campus on Monday or Friday. So unfortunately, Monday nor Friday is going to work out. Now, in a worst case scenario, I don't want to make this, a major issue. It may be possible to work out a time on a Monday or Friday where you can pick up your exam from someone other than me. But I would rather avoid that because that would require someone else to hang around in case there's a mismatch in time. Okay, so the schedule for picking up your midterm exam is as follows. Please note on the right side of the screen, there is a calendar. It happens to have my teaching schedule on it, and I'm on campus in and around my teaching schedule. Okay, now I'm in other places like the Lakeshore campus at other times, but I will not be bringing exams with me related to the North campus to the Lakeshore campus. Um, so I will not discuss time at the Lakeshore campus here. So the highlighted pink blocks are roughly when I will be available to give you your exam, which you can take with you and you can ask questions about, anything within the time block that allows for. So let me be a little bit specific about the times here. So these time blocks right here are all 12 noon to 12:35. So Tuesday, Wednesday, and Thursday, 12 until 12:35. So those are time blocks that are available to you to come pick up your exam. I'll talk about the location in a moment. After 12:35, I have to teach a class, so I'm not available after 12:35. In fact, it would probably be a good idea for you to show up by 12:30 because I have to leave about 5 minutes early to teach my class. So 12 to 12:30 would be ideal. Additionally, you have this window right here, which is from about 1:30 until, I don't know, 2:20 on Tuesday. 1:30 until 2:20 on Tuesday. And you also have a window here, which is that's going to be about 3:20 until, I don't know, somewhere around 4 o'clock. So that's another window. And finally, we got one more window down here, which I won't be staying very long after this class. So about 4:15 until about 4:45. And of course, all of these are PM. All right. So those are windows for you to come pick up your midterm exam if you would like to do so. And of course, when you pick up your exam, if you have any questions or concerns, you can hang around and ask me. My advice is to take a photograph of this or take careful notes of this pickup schedule before it goes away. Okay. Now, here is the procedure for picking up the exam. So step one is to pick a time. Step one is to pick a time. So you have to, you have to choose a time somewhere in one of these, well, I guess 1, 2, 3, 4, 5, 6 windows. Choose a time sometime in these 6 windows. Don't choose 2 or 3 times. Choose one time that you plan on coming to pick up the exam. And then step 2, you must send me a message in ideas to request the time. The reason for that is because I don't want to carry around a stack of 300 exams, because I have a large number of Tech Math 204 exams. So I do ask that you send me a message and ideas requesting the time, and be sure to indicate your normal class meeting time. For example, you guys meet on Friday at 8 a.m. You want to indicate that. Of course, your name will be in the email. So you want to choose a time. You will then send me a message to request the time, and I will confirm back with you that that should be a good time for me to bring your exam. And you just need to make sure to show up. Now, it is important that you show up promptly. If you say, okay, I'm going to show up at 12:15 on next Wednesday, if you show up 20 minutes late, I'm not going to be there. I am available strictly from 12 until 12:30. So it's important for you to be there on time. If you show up too early or too late, you might find that we have to reschedule. So please keep this in mind when you're picking up your exam. Schedule is fairly strict. So if you show up too early or too late, you might find that you have to reschedule. Okay. Now, where do you actually go to pick up your exam? Okay, where to go? Okay, so you got to go to the North Humber campus, of course, and you want to go to the LRC. That's the main big building in the front of campus, the Learning Resources Commons, LRC. You want to take the elevator up to the 5th floor. I take the elevator up to the 5th floor, and right outside the elevator on the 5th floor, if you look around, you will see the Faculty of Liberal Arts and Sciences. Okay, faculty, you'll see it above an entryway. And you want to go in and ask the receptionist for me. Ask the receptionist. Tell them that I am your instructor. And of course, they will call me at my office in 5E004, and I'll come get you, and we'll go over or answer questions or give you your exam, whatever it is you want to do during the appointed time. Okay, so all this is very important if you want to pick up your exam. So it's everything you need to know to pick up your exam. Are there any questions? Overall, the grades were sort of a mixed batch. This is a small class. We had some good, strong grades on the exam, some average sort of mid-level scores on the exam. But I also had a couple of students with very low scores on the exam. And so I'd like to see those low scores improve for the final exam. Okay, so are there any questions about anything related to picking up your midterm exam? Again, you can find your score in the Ideas gradebook. You can get access to that on the left-hand menu. Over here on the left is your Ideas gradebook, and in there you will find your score. Okay, I do not see any questions, so I think we're going to go ahead and get started. Okay. All right, so the plan for today is a little bit weird because I had to miss one of my Tech Math 204 classes earlier this week due to extenuating circumstances. So we're going to take a fairly casual pace today. We will take our break probably around 9:15, so about an hour from now. So we'll take a break about an hour from now. And we'll come back and see how much more time we need after that. But we're going to take a fairly casual pace today with the material. We've been talking about systems of equations. So back a couple of weeks ago, so it's been a while now, we were talking about systems of equations. Okay, and what is a system of equations? So system of equations, you guys had a couple of them on your midterm exam too, well, there are these problems that for whatever the application, they need to be solved for a variable or two. An example of this is you guys talked about superposition theorem, probably in your Tech 101 course. I'm not sure what that course is called. I've heard students call it Tech 101. So you guys talk about something called superposition theorem in there, and I don't know what technology courses you're taking this semester, but it's in one of your technology courses during this semester, you eventually talk about a topic called mesh analysis. And mesh analysis is essentially a sort of a distilled version of solving linear equations. So it's a very important application for analyzing the current or the voltage in a circuit, in individual portions of a circuit. So anyway, so you end up with two variables or three you could have any number of variables. And you'll have some number of equations. So for example, most of the time in the real world, you end up with n equations and n unknowns. So n is just some positive integer. So you might have 5 equations and 5 unknowns, or 7 equations and 7 unknowns, or 3 equations and 3 unknowns, or you might have 50 equations and 50 unknowns. Now, the truth is, the larger the system, the more time it will take to solve it. In this course, we only consider 2 equations and 2 unknowns, or 3 equations and 3 unknowns. So after the break today, we'll talk about, we're going to talk about a new method today. We've already talked about substitution and elimination. So we previously talked about substitution and elimination method. We're going to talk about a different method today. And prior to the break, we'll talk about the 2 equation, 2 unknown case, like this example. And then after the break, we'll talk about 3 equations and 3 unknowns. Now, you might be asking, why don't we do anything more than 2 equations, 2 unknowns, or 3 equations, 3 unknowns? Why don't we do anything like a 4 equation, 4 unknown, or 5 by 5, or 10 by 10, as we usually call it? The answer is because you would do it with a computer. It's just ridiculous how easy it is to make mistakes when you've got 10 equations and 10 unknowns. Even the best, most careful student will make mistakes when you've got 10 equations and 10 unknowns. It's just very difficult to avoid making mistakes. So in general, when you use this stuff, you use a computer algebra system like MATLAB or Mathematica or Maple or something like that. I think you guys have access to MATLAB, and so MATLAB is very good at dealing with these types of problems. It's a very good number crunching software. So anyway, we're going to look at this new method today in the context of solving systems of equations. And again, let's remind ourselves of what we are doing. What does it really mean to solve a system of equations? Well, you can think of these 2 lines, these 2 equations, You can think of them as, you know, they're lines, right? So, you know, maybe this is one of them, and maybe the other one looks like this, right? So there is apparently an intersection point for these two lines. And your job, at least geometrically, in solving systems is to find this intersection point. That's what it means to solve the system of equations. Okay. So that's what you do when you use substitution or elimination. All right. So today we're going to focus on a new method, and that new method is called Cramers Rule. Sometimes it's called the determinants method. Sometimes it's called the determinants method. So to understand quote unquote Cramers rule, we have to first understand what determinants are. Now, before the midterm exam, I think it was the week before or something. I think it was the week before the midterm exam. I talked about how you can actually convert a system of equations into some kind of a matrix. And the idea is you just, let's fill in coefficients here. Let's put ones in there. You just peel off coefficients. And those coefficients are really all that's important ultimately in solving systems using the elimination method. So we can sort of rewrite this, and we're not going to focus too much on this today, probably focus more on this next week, but you can put a little dotted line there to denote the equal to sign locations. So this is called an augmented matrix. And it turns out that we use this augmented matrix to compute, we can use it to compute determinants. Okay, now you can only compute the determinant of a square matrix. This is not a square matrix. It's got 2 rows and 3 columns. A square matrix has the same number of rows as columns. So this is not a square matrix. So strictly speaking, we cannot find its determinant. However, we can find the determinant of some kind of a square matrix. So for example, A, B, C, D. We'll call this matrix capital M. We can find the determinant of a square matrix, and then the procedure is very simple. Now there's some notations. We usually use the notation like this. This is a common notation, det of the matrix M, or sometimes people will write dt of M, where M is the matrix, whichever makes you happier. And so the determinant is calculated by simply multiplying down the diagonal A times D, putting a minus sign after the D, and then multiplying along the secondary diagonal. It's that easy, right? So the determinant of the matrix M is just AD minus CB. So let's look at some examples of calculating determinants. Find the determinant of the matrix 3, -1, -2, 4. Okay, so to find the determinant, we usually write down the matrix. And by the way, some people use square brackets, some people use parenthesis. It really doesn't matter. You know, whatever makes you more comfortable. Okay, so we're going to multiply down the primary diagonal first, 3 times -1. Then put the minus sign. You always put that minus sign in there. And then multiply down the secondary diagonal. Now, you have to be careful with your arithmetic here. Your arithmetic could be the source of making mistakes, so you got to be careful with it here. That's going to be -3 plus 8, which is 5. So the determinant of this matrix is 5. Now, in just a few moments, we'll see how this helps us to solve systems. Okay, let's do another one. Find DT of m if m is equal to 3, 1, -6, -2. So we want to find the determinant of this matrix. Okay, so again, we multiply down the primary diagonal. It's called the primary diagonal. We put a minus sign in there. We always put that minus sign in there. And then we multiply down the secondary diagonal. That's called the secondary diagonal. I actually multiply it up the secondary diagonal, not down. It doesn't really matter. So the determinant of this matrix is 0. It turns out matrices whose determinants are 0 are kind of special. Okay, so with this in mind, I'm going to show you Cramers rule for a system of 2 equations and 2 unknowns. Now, I want to point out that I'm going to be writing a lot of stuff here in the next minute, but you don't need to memorize any of it. And for 2 reasons, you don't need to memorize any of it. Number 1, we give you the following information on a formula sheet on your final exam. And number 2, I'm going to teach this to you in a way such that you can avoid memorization completely and you can reason out Cramers rule without even the formula sheet. So I'm going to show you that afterward. So what is Cramers rule for a system of 2 equations, 2 unknowns? So we call that the 2-by-2 case. Okay, so first of all, you have to have a system of equations with abstract variables. So here, A1, B1, and C1 are just some number. A2, B2, and C2, again, just some number. So here's your system. So by Cramers rule, the solution is the determinant of A1, B1, A2, B2 That's your denominator for your x value. It is also the denominator for your y value. The numerator is found by replacing the x column coefficients of the denominator with the right-hand side. So I'm looking for x, so I'm going to replace the A1 and the A2 with C1 and C2. I'm going to talk about this a lot, so don't freak out if you didn't quite hear everything I just said there. For the y value, I'll use my denominator here, and I'll replace the y column, that is the b's, with C1 and C2. Okay, so we give you this on a formula sheet, and so you don't need to memorize it. But again, you won't even need the formula sheet if you pay close attention to what I'm about to show you. Okay, so let's do an example. Okay, so what Cramers Rule says is you've got to compute determinants using the coefficients generated or the coefficients from the matrix that results from this system. So I want you to notice here that the denominator in both cases is the same. You look carefully, everything is the same in the denominator. The denominator is sometimes called del, not to be confused with delta. So delta is this symbol, this is delta. Del is delta. Greek letter, uppercase D, I guess, delta. Del is the delta turned upside down, and it's spelled DEL. So this is sometimes called del. I'm not going to use that very often, but sometimes it's called del. It's the determinant in the denominator. And of course, it's the same for both x and y. And when we get to the 3x3 case, it'll be the same for x, y, and z. If you have a 10 equation, 10 unknown, it's the same denominator across all 10 variables. Yeah. So notice here that this denominator determinant is simply the coefficient matrix from the left-hand side portion of your system. So, in other words, the coefficients of x and y. Right? That's what it is. Now, let me backtrack so that I don't have all this color all over my screen. All right, so what I'm going to do first is I'm going to find this denominator determinant, this thing called del. Okay, now in order to figure out del, I just need to look at the left side of my system. and I want to pull off the coefficients. So I'll write del is the determinant of, okay, so it's just going to be 2, 1, 1, negative 3. 2, 1, 1, negative 3. Okay, so that is my denominator for my solutions. All right, so what is that determinant? Well, that's a pretty easy determinant. 2 times negative 3 minus 1 times 1. Okay, so that's going to be negative 7, I believe. And that is my denominator. So I immediately now know my denominator for both my x and y is negative 7. So I've calculated, quote unquote, del. Now, how do I get the numerators? So I need to get the numerators for x and y, and you can see the numerator is again some kind of a determinant. So here is my personal little trick. I didn't see this until I noticed it, and it does work in general, and that can be shown for any n by n system. So the way my little trick works is, if you look carefully here, you'll notice that if I'm looking for x, then notice I'm really using my denominator determinant, but I'm replacing the x column coefficients with the right-hand side. So here's what I do is I copy down del, the matrix that I had over here. Actually, let's do this over on the right. So let's just copy this and paste it. There we go. There it is. So I'm just going to copy it. So what I'm going to do is I'm going to, first of all, decide which variable am I looking for. And I'm going to decide to look for x first. So I'm going to look for x first. So what I'm going to do is I'm going to identify the column of x's in my system, which is the 2 and the 1. I'm going to erase them. I'm going to erase the 2 and the 1. So let's erase 2 and 1. Okay, you'll see that I erased the 2 and the 1. In place of the 2 and 1, I'm going to put the right-hand side portion. That's the 1 and the 2. So I'm just going to copy and paste the right-hand side. Okay, that's not working. Just copy, paste 1, 2 in there. So and this works every time. All right, so I'm going to compute the determinant of that. Okay, so what is that? 1 times negative 3 minus 2 times 1. That's negative 3 minus 2, negative 5. So my x value for my solution is 5 over 7. Now, next I have to find my y value. So let's come over here to the y value. Now to find my y value, again, I'm just going to use del as my starting point. So I'm going to copy it again. Let's copy it down here. There's del. Okay, so this is to find my y value. So what I'm going to do is figure out, okay, which column of values is associated with the y value? Well, you can see right here, there are the y values. So the y values correspond to the 1 and -3. So I'm going to replace the 1 and the -3 with the right-hand side. So what is the right-hand side? That's 1 and 2. So let's do that. This works every time. And then I'm going to compute the determinant. Two times 2 minus 1 times 1. So that's 4 minus 1, which is 3. Put that in the numerator, and you're done. Okay. Now I'm going to check this with Wolfram Alpha just to verify. See what Wolfram Alpha says. Wolfram Alpha is a pretty good little system here. It'll help us check our solution. So let's say solve the system. Solve 2x plus y is equal to 1, and x minus 3y is equal to 2. See what it gets. So it gets x equal 5/7 and y equal -3/7. Okay, so Wolfram Alpha agrees with our solution. Okay, so we're going to do some practice problems with this, so don't get too worked up just yet. Okay, however, are there any questions about this problem? We're going to do another one. Okay. Okay, let's solve another one using Cramers Rule. By the way, on the midterm exam, I'm very flexible with methods that students use. On the final exam, there is some expectation, you should expect on the final exam that you may have to use a particular method to solve a system. For example, you may have some problem where you need to use determinants, like doing solving systems like this using this method. There are going to be other methods for solving systems a little later on. So be aware that you can't just pick and choose. There is some general expectation that you understand how to use all of the methods going forward at some level. Solve using determinants. Okay. So again, I'm going to make a little, I'm going to write my solutions down here to get them prepared. So I've got y equal, and they're always going to be fractions, but well, they may simplify or reduce so that there is no fraction, but your answers are always going to be fractions, almost always. So the first thing you do is find del. That's the denominator determinant. So what you should do is identify the leading coefficients. Okay, and of course, you've got the right-hand side coefficients, or constants rather, as well. So to find del, we just take the determinant of the blue highlighted coefficients. the side with the x and y. That's going to be 3 times -4 minus 1 times -2. I think that's -10. So immediately I have half of the work done. That's the denominator for both my x and y. Now, to find the numerator, I'm going to just copy del as it is. I'm just going to copy it. Okay, now I have to choose a variable that I wish to isolate, find first. I have to choose a variable. So let's say I choose x. Let's just say I'm going to find x first. So what I have to do is go up here and say, okay, well, what coefficients are associated with my x's? Well, that's the 3 and the 1. So I'm going to go over here and I'm going to erase 3 and 1. And I'm going to replace it with 1 and -3 from the right-hand side of my system. I hope you see how that works. It's pretty simple. It's a good method. It works really well for a small 2x2 system of equations. Okay, so I want to find the determinant here. So that's 1 times -4 minus, be careful with your signs here. It would be very easy to get signs mixed up. Let's see, that's going to be -6, I believe, which is -10. So x is just 1. Because -10 divided by -10 is 1. Now I need to go through the same process for my numerator for my y value. So I'm going to copy del, copy it over here to the right. And I'm going to replace, I'm now looking for the y values, for the numerator for my y value. And what I'm going to do is I'm going to figure out, okay, what are my y coefficients? And so those are the y coefficients right there. So I'm going to replace those in del. That would be the -2 and the -4. And I'm going to replace those with the right-hand side of my system. So that would be 1 and -3. Again, here's 1 and -3. And I'm going to compute the determinant. So that gives me -9 minus 1 is -10 again. Interesting. So apparently my solution is, or the intersection point is at the coordinates 1, 1. Let's see if Wolfram alpha agrees with that. And it does. So the intersection point is in fact at 1, 1. Right, so. All right, any questions about those two examples? Now, because some students had a little trouble on the midterm exam, we're going to do one more before I give you one to try at your seats. I had a couple of students that had some difficulty on the midterm exam, so I want to give you another opportunity to see one more example before we give you one to practice at home or on campus, wherever you are right now. If you have any questions, please ask. Okay, so next example, we want to solve the system. Okay. Oh, let's do one that you have to kind of rearrange a little bit. Sometimes you get equations like this. I want to show you how to do something like that using Cramers Rule. Now, in order to use Cramers Rule or determinants, you have to get it in the same form every time. So, in other words, it has to be in the form ax plus by is equal to c. Okay, your equations have to be in this form. So, in order to do this problem, we need to move the 2 and the -1 to the other side. Okay, and then we'll use that. So I'm going to subtract 2 from both sides of equation 1, and then I will add 1 to both sides of equation 2. So this is what I should use. Should use this. Do not use that. Okay. Otherwise, Cramers Rule will break. Okay, so this is what we want to use. All right, so now let's set up and do Cramers Rule. All right, so let's see. X is equal to some fraction, and then Y is some fraction. So I want to first determine the denominator portion. That will be del. Okay, and while I'm here, let's highlight the coefficients on the left side. And then on the right side, we have -2 and 1. All right, so del will be the determinant of that left-hand side coefficient set. Okay, so the determinant here is -2 times -6 minus 1 times 1. So I believe that's 11. So 12 minus 1 is 11. If you guys see me make a mistake, let me know. Okay, so there is my denominator. Now, next, I have to find the numerators. So in order to find the numerators, I have to start with one of my variables. I'm going to start with x. So what I'm going to do is look up, and I'm going to see, okay, what are my x coefficients? Okay, those are my x coefficients, which correspond to these two. So I'm going to erase those. Oh, let me copy first. Forgot to copy. Okay, so I'm going to replace the -2 and the 1. And in place of it, I'm going to put, oh, interesting, -2 and 1. So in this case, you get the same thing. I didn't mean for that to happen. Oh well. Okay, so -2, -6, minus, we already know what it is. It's 11 again. So my x value is 1. Now I'm going to go to my y value. Again, I'm going to copy del down, or the matrix. And this time I'm going to replace the y values, the y column, which is the 1 and the -6. I'm going to replace those with the right-hand side. Now that gives us -2 times 1 minus 1 times -2. Do that arithmetic and you get 0. Now remember, 0 divided by a fraction is just 0. So I'm glad this came up, because now you're reminded that 0 in the numerator is okay. It's 0 in the denominator that's a problem. So let's see if Wolfram alpha agrees with our solution. And by the way, when you're doing practice problems, I recommend using Wolfram alpha or one of these systems. We'll start with the original system, but you can type in either one. I'll start with the original one. 0. Let's see what it says. X is equal to 1. Y equals 0. Okay. All right. So those that's our intersection point for our two lines. Okay. Now you've seen 3 examples of using Cramers Rule for 2 equations, 2 unknowns. Are there any questions? Are there any questions? So this works pretty well for 2 equations and 2 unknowns. Now, after the break, you're going to see that it gets a little bit more complicated with 3 equations and 3 unknowns. Let's see if we have any questions here. Okay, no questions. If you happen to miss the first 30 minutes of class where I was talking about how to pick up your midterm exam, my advice is, after the recording goes up for this lecture later today, make sure to look at it and watch the first 30 minutes so you know how to pick up your midterm exam. Okay, so what we're going to do now is we're going to go into live poll. What's it called today? Live poll 7. Live poll 7. And we're going to work a question here. Okay, now I'm going to give you guys 10 minutes to do this question. I'm going to give you 10 minutes. It is, I want to see if you understand what I have just taught you. Okay, so this is basically asking you about, can you solve a system using Cramers Rule? Can you fill out the matrices about which matrix is which? Can you compute the determinants? And then finally, can you give the solutions? Okay, so I'm going to be giving you guys 10 minutes. I notice as of right now, we only have 1 student in the live poll. So I hope everyone will take part. Maybe folks are taking a moment to get in. Take a few moments. I'm going to give you guys lots of time on this. I'm going to give you 10 minutes. We'll come back and work it, and then we'll take a 10-minute break. Okay, so I'm giving you 10 minutes because I want you to have an opportunity to work through this one. Okay, so I'm going to give you a little bit more time. Let's say 8 minutes, because I don't think 10 minutes is necessary. It's probably a little too much. Let's say 8 minutes. And of course, when we return, we will take a look at and work this question. Now, what I'm going to do is leave my work for the last problem, the last two problems on the board, so you can have some kind of guide or reference. Okay. All right. So take about the next 8 minutes, and when you get back or when you're finished, go ahead and submit. I will come back and answer your questions, and we'll go over it together. Okay. All right. I'll turn my mic and camera off while you guys work. If you have any questions, feel free to post questions in chat. Okay, welcome back. All right, let's see how many of you have tried this problem. So I've only had 5 students in the live poll, and I've only gotten 2 results. This is a little bit concerning because at least 2 students out of, there's only 8 of you, at least 2 students did fairly poorly on the midterm exam. So if you're not taking part in the practice, you can't expect to learn. Part of learning is practicing. You don't learn by just watching other people. You've got to do a little practice. So if you scored not so great on the midterm exam, my advice is to get going, get to practice. When I offer you a practice problem like this, give it a try. Okay, because you're missing a golden opportunity to practice the material in the context that you could probably see it on an exam. Okay, so for those of you that are not taking part, if you're having trouble in the course, my advice is to start taking part. Okay, anyway, let's go ahead and go through this. Again, I only have 5 students. I've got 3 results now, so at least some of you are working. I appreciate that. You will benefit yourself from it. So let's see if we can figure this out. So notice here that on the screen, it gives us right here in the middle, Cramers Rule. Now, right here is Cramers Rule. And in this case, A is what I was calling del before. So what it wants you to do is figure out it just wants to know what the matrix A is first. So what is the matrix A? So A, or it's the same as it's the same as the matrix that's used to find del, and it's just the coefficient matrix from the left-hand side. So it's these x's and y coefficients here. So let's just go ahead and fill those in. -7. I think you can tab through this. -3 and 8. That should be your matrix A. Now, scrolling down, rather zooming out, remember the numerator matrix and for both the x and y they're similar to del. So if you want, you can just copy del down and then just replace, the appropriate coefficients. So with M1, which is what we're looking for here, M1 is it's the matrix of coefficients where we remove the -7 and the -3 and replace it with -30 and -42. So, and of course, matrix 2 or M2 is the same idea, except we replace not the x column but the y column. Okay, so if I just simply copy down my matrix A, and then I replace the y column, so that would be this one and this one, with my right-hand side, -30 and -42. Okay, now I just want to test to see if I've got the matrices right first. So I'm going to press submit just to see. Okay, so I've got the matrices right. So the next thing it wants me to do is find the determinant of each of these. So I'm going to do that off to the side here because I'm going to need a little bit of room for that. Okay, let's just let's flip sides here. Okay, so All right. By the way, your technology instructors do use this method occasionally. All right, so let's see, -7 times 8 minus -3 times -4. So that's -56 minus 12, I believe. That's -68. All right, so -68 is my determinant of A. What's the determinant of M1? Okay, I'm probably going to get a calculator out for this one because this one's a bit more complicated. Yeah, this one's a bit more complicated, so get a calculator out for it. Negative, let's move this somewhere else. -30 times 8 minus -42 times -4. So -408. Okay, so that's the determinant of M1. And finally, we need to find the determinant of M2. All right, so again, I'm going to use the calculator here because this one's a bit arithmetically complicated. And by the way, use your calculators if you have trouble with negative signs and stuff, because sometimes you'll get stuff like this, and it does look very messy, very easy to make mistakes. -7 times -42 minus -3 times -30. Positive 204. Let's see if those are correct. And they are. Okay, so far, so good. Are there any questions so far about what I have done? Any questions so far about what I have done? This is your fourth example using Cramers Rule. Yeah, it's very important. Your technology instructors may use this. Very, very important. Okay. No questions. All right, the last thing to do is find X and Y. Well, remember, according to Cramers Rule, the determinant of M1 divided by A is X. So that will be -408 divided by A. Which happens to be 6. And then Y is M2, the determinant of M2 divided by A, determinant of A. And that's -3. Let's see if this is correct. and it is. So our solution is 6 comma negative 3. Okay, I'm going to leave that open during the break so you guys can type in your answers if you want. Are there any questions before we go off for our 10-minute break? Any questions whatsoever before we go off on our 10-minute break? Okay. All right, so we're going to break for 10 minutes. Make sure you press submit. After we return, we will start talking about systems of 3 equations and 3 unknowns. And let me go ahead and warn you that if you are having trouble with this, after the break is going to be really tough because what we do after the break depends on your ability to do these calculations. Okay? All right, so let's break for 10 minutes and we'll return and start after that. Okay, I'm going to write this something down and then we will get started. So bear with me for just a moment longer. Okay, so welcome back. I was just taking just a moment here to write down what we're going to talk about next. So we're going to talk about Cramer's rule for a system of 3 equations and 3 unknowns. That's what we're going. That's where we're going to go next. And of course, this is it. Again, there's nothing here you need to memorize, but if you understand the patterns that I was using in the previous 4 questions before the break, there should be no problem in transferring this knowledge over to the next topic. Well, the additional equations. Okay, so before we get into that, are there any questions about what we have talked about so far? Any questions about Cramer's rule for solving systems of 2 equations and 2 unknowns? Again, I'll say that if you missed the first 20 minutes or so of class, my advice is later tonight, go back and look at the first 20 minutes because there are some important announcements in there related to how to pick up your midterm exam from me on campus. Okay. All right. I do not see any other questions, so let's go ahead and move on. All right. So Cramer's rule for 3 equations and 3 unknowns it's the same idea as 2 equations and 2 unknowns. There's really, if you just remember the process that we used for setting up our matrices, the only additional thing you have to learn is how do you find the determinant of a 3x3 matrix. Okay, and I'm going to be showing you two ways to find the determinant of a 3x3 matrix. However, I'm only going to recommend you use one of the methods, because the other method, the more complicated method, is unfortunately very complicated in general. So I'm going to caution you about the use of these determinant methods. And by the way, I'm not sure how to use the calculator, but I believe that there's probably a way to deal with matrices in your calculator. Yeah, so apparently, and you guys are welcome to use your calculator. So if you go into the mode on your calculator, item number 6 is called matrix. So item number 6. And you can choose a matrix that you want to use. Let's say we want to use matrix A. And then what you can do is you can choose the dimensions. So for us, it'll be well, at least for this problem, well, actually, we can go up here and do one of the problems we just did probably with the calculator. Let's say we want to deal with this 2x2 matrix right here. I would use item number 5 in that case. And then you can just fill in your matrix. An entry at a time. Okay, make sure it's correct. And then I think you just press equal, and then I believe you use the matrix operation button down here in the bottom middle of the calculator. It's called matrix. Maybe data. Okay, well, I thought I knew how to do it, but apparently I do not. There's probably a determinant calculator somewhere here. I'm just not sure where. I thought it would be in this matrix submenu down here, but apparently it's not. And that just gives me the dimensions. Let me just look for a minute here and see. Let me just try something right here. ABS of oh, there it was. Okay. There it was. So shift matrix. Okay. So I think what happened is I have to exit out of the matrix mode. So if you're in the matrix mode and you're accessing your 3x3 or 2x2 matrix, which we have here, once you've entered it, you have to clear and all clear. Yeah. And then you press shift and matrix, and then there's this item number 7 for determinant. And then you have to pull up your matrix. So you go back into matrix mode, you get data, and then it's matrix A that we want. So I guess you call it A. Okay, it's called A. So let's see. Yeah, I'm just sort of trying to figure this out. So 7, and then maybe it's alpha A. Let's see if this works. No, it doesn't like that. Well, like I say, if you figure out how to use your calculator, you can use it to calculate these determinants. Just a little bothersome here that Oh, maybe I'm supposed to use MAT A there. Maybe that's what I'm supposed. So yeah, 7 for determinant, and go back into the mode again, and then maybe press 3 for matrix A. I bet that'll give the determinant. There we go. So yeah, that's how you do it. That's how you do it, at least with the Casio sequence or series calculator. So again, what you do, I want to watch very carefully here, is you go into the mode to get to the matrix mode, press 6. Then you have to choose a matrix you want to modify. Let's say we want to use matrix B this time. And let's say I want to compute the determinant of -7, -4, -3, and 8. So that's a 2 by 2 matrix. So then I'm going to type in my entries one at a time. Okay, press the all clear key for B, and then you press shift and item number 4 down here to get the matrix sub options, and then 7 is the determinant. And then you go back into those sub options again, and then choose the matrix that you've modified. I guess you could use MAT answer as well, but I think it was matrix B. Close the brackets, and that gives us our determinant. Yeah, it's a -68. So if you can figure out how to use your calculator, you are welcome to use your calculator to find determinants. Okay, and I'll actually go through using the calculator to find determinants of 3 by 3 matrices here as well. Okay, so anyway, back to Cramers rule. What I was saying before we got on that calculator tangent is it's the same process. You'll see here that when you're looking for x, well, the denominator, let's start with the denominator. So the denominator determinant is just the coefficients on the x, y, and z side of the equation, right? Yeah, it's the coefficients on the x, y, and the z. And of course, it's the same here and here, right? You just copy down what you got for the determinant for the denominator for x. Okay, it's the same idea. Okay, so oops. All right, so again, the process is still the same for finding x, y, and z, right? So if you're looking for x, you erase the x column and replace it with the right-hand side. Right, the right-hand side is D1, D2, D3. It's the same process. Notice for the y's, rather for the y. What I'm going to do is I'm going to replace the middle column, because the middle column for the b's are associated with the y coefficients. I'm going to replace the b column with the right-hand side. So you can see that right there. And finally, the same is true for z. The z coefficients are the c's, C1, C2, C3. And you'll notice, given my denominator matrix, I've replaced the c's with d's in the numerator. So it's the same process that we learned for, and it's the same for 10 by 10 system too. This does not change no matter how many variables you get involved. Okay, so we're going to do, before we do an example, we have to figure out how to take the determinant of a 3x3 matrix. How do you take the determinant of a 3x3 matrix? So we're gonna go off to the side and figure that out. Now, there are several methods for finding determinants of 3x3 matrices. And the only one that works for any n by n matrix, so any n by n, so 5 by 5 or 20 by 20 or 100 by 100, is called the Minor's method. Now, the Minor's method is a huge headache, okay? Sometimes I teach it, and students, you can see the look on their face when I teach them in the classroom. They do not like the Minor's method because there are so many exceptions and pattern changes that are involved. I am not going to teach the Minor's method. I will simply say that if you get a system of equations that is larger than 3x3 in another course, you will not see anything larger than 3x3 in this course. 3x3 is the largest matrix you will encounter. But if you see something larger than a 3x3 matrix, my advice is do not use the Minor's method. Do not use the Minor's method. I would go get MATLAB and ask MATLAB to do it. MATLAB is a piece of software that you guys have available to you on campus. You actually have access to it, I believe, as a installable software as a student. Use MATLAB because you do not want to use the Minor's method unless you've had lots of linear algebra previously. If you know what the Minor's method is and you're comfortable with it, feel free to use it, but I'm not going to teach it in here because it is a huge, huge headache. The second method I call the wraparound method. Is easier. And that's what I'm going to show you in here. Okay. And method number 3 is the calculator. Okay. So I'll show you the wraparound method, and then we'll do some with the wraparound method, and then we'll do some with the calculator. Okay. So here's how the wraparound method works. Let's say we have a 3x3 matrix. And let's make sure these numbers are not too large. Okay, so I have a 3x3 matrix here. Let's say I want to find the determinant of this matrix. Okay, so we want to find the determinant of M. So the wraparound method is not too difficult, but you have to be careful with it. So here's how I do the wraparound method. All right. So what I'm going to do is I'm going to write my matrix down, and I'm going to leave lots of space around it. So let's see, 1. So I'm going to spread the numbers out a little bit. Not much. Just need to leave plenty of space so things don't get crammed, and make sure everything lines up nicely. Okay. All right, so there is my matrix. Now, with the wraparound method, here's what you do, and this is what you've got to be very careful with. Okay, so what I'm going to do is I'm going to start with the lower left triangular portion of my matrix, the lower left. So what do I mean by the lower left? I mean that portion right there. I'm going to copy that, and I'm going to pick it up and move it to the right-hand side and attach it on to my matrix. Shift that -3 over. And you can see I've done it right there. Now let me get rid of the highlighting. Make sure you see where that's coming from. I'm going to do the same thing with the lower right-hand triangular portion. The lower right-hand triangular portion. Yeah, that would correspond to these elements. I'm going to pick that up, copy it, and attach it on the left side. And believe me, this method is a lot easier than minors, using the minors method. So we're actually, there isn't much left to do. All right, now we're going to find our determinant. So here's how you do it. All right, so you use this weird pyramid-looking matrix. So the key to this method is you're going to use these three elements as a starting values or starting calculations. These are how you're going to do the determinants calculations. So what you do is you now multiply down and to the left. Sorry, down and to the right. 1 times 1 times 1. So what's 1 times 1 times 1? That's 1, right? 1 times 1 times 1 is 1. Okay. All right, move to the next. All right, so let's see, we had 1 there. Okay, let's move to the next. 2 times 0 times 1. 2 times 0 times 1. Well, that's 0. Write 0 down. Finally, the final right-hand diagonal. -2 times 4 times -3. You just multiply them together. So that's what? -8 times -3 is +24. Okay, add all those up. Okay, that gives you 25. Now put a subtraction sign and a bracket, a big bracket. And do the same thing, but instead of going down and to the right, you know, we did down and to the right the first time. Instead of going down and to the right, go down and to the left. Go down and to the left. All right, let's start with the first one. Well, the first one is 1 times 0 times -3. That's 0. The next one, 2 times 4 times 1. That's 8 times 1 is 8. Finally, -2 times 1 is -2. Make sure you put that -2 in there. So -2. Do this arithmetic, and that's your determinant. So that's 25 minus 6, which I believe is 19. Let's check this with the calculator. So that way you're seeing the calculator method with the wraparound method. Okay, let's use the calculator to check this. Okay, so let's go into the mode. We're going to use the matrix button. So number 6. And let's use matrix A. And this is going to be a 3 by 3 matrix. So 1. All right, so I got to enter these entries: 2, -2, 4, 1, 0, 1, -3, 1. Okay, make sure we have our matrix correct. Okay, press the all clear. And then we're going to go into our matrix submenu. And we're going to press determinant. Go back into our matrix submenu. And we want to use matrix A. And we get 19. So you can see right there, this works. Now, believe me, this method, whether you're using calculator or you're using the wraparound method, both methods are far easier to remember than the minors method. Okay, so if you are interested in the minors method, I'll invite you to do your own research, but I do not recommend it unless you intend to be like a student of more pure mathematics. You guys are not math majors at a university. You're interested in the applications, right? So the wraparound method or a calculator or computer algebra system will be good enough for you. Okay, so I invite you to use any of these methods. I'm not going to get picky about it. But remember, if you're going to use your calculator method, use the calculator to do it. It's an all or nothing situation. You either get all credit for doing the problem or you get 0 credit if you get it wrong. So if you're going to use your calculator, please make sure you know how to use it correctly. All right. So now that we know how to find, let's do one more where we find the determinant of a matrix using the wraparound method. Okay, so let's do another one using wraparound. Okay, let's say we have a matrix called N. And let's say N is the matrix 0, 2, 1, 3, 6, 5, 1, -1. Let's make it 0, 0, -1, 1. I don't want to put very large numbers in here because very large numbers makes our life miserable. So, all right. So again, if we're going to use the wraparound method to find the determinant, then what we need to do is we need to draw our matrix with plenty of space and line everything up. In fact, I'm using a grid. I'm using the grid on my screen to help me keep everything lined up. You don't necessarily need to keep it that straight, but it kind of helps. Okay, now I have to do this game where I've got to cut, copy, and paste. Okay, so on the bottom right, I've got 5, 1, -1. I'm going to take this portion right here and attach it over here on the right. I'm going to do the same thing with this bottom left portion here, 3, 0, -1. I'm going to copy that and paste it over here on the right. Okay. So now what I'm going to do is I'm going to multiply down my diagonals. Oh, my things didn't line up because I used too much space in there. Sorry about that. So I'm going to multiply down and to the right. Multiply everything down to the right. Add the quantities together when you multiply down and to the right. So the first one is 0 because it's got a 0 in it. 0 times 6 times 1 is 0. The second one is 0 because it's got a 0 in it. 5 times 2 is 10. 10 times 0 is 0. So it conveniently here, it starts out as 0 plus 0. Finally, 1 times 3 times negative 1. Let's see, that's 3 times negative 1 or negative 3. Add all those up. 0 plus 0 minus 3 is negative 3. What did I do next? I put that big minus sign in my big set of brackets. So minus sign, big set of brackets. And now I'm going to go down and to the left instead of down and to the right. So I'm going to go down and to the left instead of down and to the right. And I'm going to add those products up as well. Okay. The first one is 0 because it's got a 0 in it. Oops. 0 minus, plus. And then the next one is 2 times 3 times 1, that's 6. And finally, the last one is 1 times 6 times 0. There's a 0 in there, so 0 is the result. Okay, so my determinant should be negative 3 minus 6. Minus 9. Let's check with our calculator. Okay, we're going to go back into our mode. Number 6 is matrix. I'm going to choose matrix A, and matrix A will be a 3 by 3 matrix. Enter my entries just over top of the previous entries. Okay, let's make sure our matrix is correct. Okay, it looks correct. I'm going to press all clear, and then I'm going to go into my matrix functions menu, and I'm going to press determinant, number 7. I'm going to go back into my matrix functions menu, and I'm going to choose matrix A, which is the one I modified. Press equal to, and sure enough, we get negative 9. Okay, so your calculator will do this. Also, another thing you can do is if you don't want to use minors and you do not want to use and you don't want to use, like, maybe your calculator doesn't allow you to calculate the determinant of a matrix. What you can do is you can use Wolfram Alpha. You can use Wolfram Alpha. And what Wolfram Alpha will do is you can choose, you can choose. Now, I'm not going to give you a 4x4 or a 5x. Nothing in this course will be larger than 3x3. But, you can, you can go in and add a huge matrix. Like I could take the determinant of a 5x5 or a 4x4, or, you can add arbitrarily, you can add a huge matrix if you want. So let's see, we could take the determinant, find the determinant of, and then you feed it this huge matrix. Let's say our matrix is, I don't know, I'm just filling in entries here. I'm just making things up as I go. Okay, let's see what she says. Apparently, the determinant of this matrix what about this? Well, for some reason, it's only using 2, 3, 4, 2, 3, 4, 4. Okay, I don't know why it's not computing this one. Anyway, I guess you guys will have to use MATLAB or something. I figured Wolfram Alpha would do this for you. I don't know why it will not accept this. Oh, it's maybe because it's got a bunch of zeros in it. Let me remove some of these zeros. Let's see what it does in that case. No, for some reason it sticks with this, which is not the correct matrix. I'm not really sure what's going on. But anyway, there are many options out there for computational mathematics. MATLAB is a really good one you guys can use if your calculator does not calculate large matrices. Okay, so anyway, let me remind you that in this course, you are only responsible for up to 3 equations and 3 unknowns. Okay, so you're not going to have to worry about 5 by 5 or 10 by 10 or whatever, anything very large. Okay, so up to 3 by 3 is the largest you will see. Okay, so let me see what we've got on our time here. Okay, so we've got time to do, I think, one example here, because these do take a long time to do. All right, so let's actually use what we've learned here to solve a system of 3 equations and 3 unknowns. Okay. So let's say we want to solve the system 2x plus y minus z is equal to 1. X minus 2y plus 2z is equal to 3. And then let's say minus 3x plus y minus, let's say plus z is equal to -1. So let's say we want to solve this system of equations, and we're going to use Cramers rule here. All right, so we've got to compute several determinants. Okay, first of all, the determinant, well, first of all, we've got 3 variables, x, y, and z. And remember that the denominator for each of them is the determinant on the left-hand side. Okay, so the determinant of that left-hand side. So what I'm going to do is I'm going to find the determinant of my left-hand side coefficients. All right, so let's write that out over here to the right. Okay, so let's write it out over to the right here. So let's see. My left-hand side will be 2 And then the y is 1 here, so there's 1 there, and then -1. Going down to my x's, 1, -2, 2. And then down to my third row, -3, 1, and 1. So I'm going to now use the wraparound method to find this determinant. Okay, so I've got to reattach some stuff here. I'm going to go ahead and do the reattachment. Okay, and then I will do my multiplications down to the right and then down to the left. Right? Multiply down, add those up. Okay, so if I go down to the right with the first one, that's just going to be -4. -4. Plus, down and to the right again, that's going to be -6. Down and to the right again, that's going to be -1. Add all those up. So -4 plus -6, -1. I think it's -11. Okay, I'm going to move my X, Y, and Z's down a little further. All right, so that should be -11. Now remember, what did we do next? So we subtracted and we put this big bracket. And then we do our down to the left instead of down to the right. Down to the left. Okay, so the first one is 4. The next one is 1 times 1 times 1, which is 1. And then the last one is -6, I believe. -2 times -1 is +2, and 2 times -3 is -6, I believe. Okay, so we need to do this arithmetic. -11 minus 4 plus 1 is 5. 5 minus 6 is -1. So that's -11 plus 1, or -10. Okay, that was the determinant of the del on the left-hand side. So that's my denominator for all my answers. Let's check this with the calculator to see if it's correct. Okay, let's mode and then matrix mode. Let's choose matrix A again, and matrix A will be 3 by 3. So let's choose 1. And then let's fill in our matrix. So what was it? 2, 1, -1. And then the next one is 1, -2, 2. And then -3, 1, 1. Let's make sure it's correct. So again, I'm just using the left-hand side of my system, the X, Y, and Z side. Okay, it looks correct. So I'm going to all clear. And then I'm going to compute the determinant by going into the functions mode for my matrices. So matrix A, see if we get -10, and we do. So that is correct. Okay. Now, to save us time, since we've done several examples with the wraparound method, what I'm going to do is I'm simply going to go in with my calculator and figure out what the determinant of my numerators are one at a time. So the way I'm going to do that is I'm going to go into my mode, and then I'm going to go into matrix A, and I'm going to use the old matrix, the denominator matrix. Here it is. And remember, all I have to do to find the numerator is replace the x column. So that's the what is it? The 2, the 1, and the -3. So that corresponds to the 2, 1, and -3 here, and I'm going to replace it with the right-hand side. So let's see if I can do that. Okay, 1. I don't know, mess with that. Let's go down at 3, -1. Okay, so I should have my new matrix now. Press all clear, shift matrix, find the determinant, number 7, shift matrix. And I want to use matrix A, and it turns out that's -10 as well. Let me make sure that that's stored, because that's -10 divided by -10 is 1. But let's see if that's stored correctly. So I'm a little bit concerned it did not store. Go back into my matrix mode, and let's look at matrix A again, which is 3 by 3. And it should be 1, 3, -1, 1, -2, 1, -1, 2, 1. That's correct. And so it must be correct. Okay, -10 divided by -10 is 1. So apparently x = 1 is my first part of my solution. Now, here is my del. My del matrix. So I'm going to go back and change it so that the middle column is now my right-hand side. So the middle column becomes my my right-hand side replaces the middle column. Okay, so let's see if we can do that. Now, my matrix has been changed. I need to change the first column back, and we'll leave the second column alone for now. So change the first column back to what it was, 2, 1, -3. And then I need to replace my middle column with the right-hand side. 1, 3, -1. Press all clear after you've pressed enter. And now let's find its determinant. So the calculator really makes this stuff more easy. I do recommend it. Uh-oh. Let me do that again. 7 for determinant. And then we want 3. And that gives us -5. And so y is equal to 1/2. Now we'll do the last one with the wraparound method again. Do the last one with the wraparound method again, because we want to practice that one more time. So with the wraparound method, we'll go back to this. Oh, no. So with the wraparound method, we need to go back to our del matrix. But remember, we have to modify it for our numerator. So 2, 1, -1, 1, -2, 2, -3. And by the way, you may be asking, isn't there got to be an easier way to calculate these determinants? No, not much. I can't think of anything that's much easier than this wraparound method, except the calculator. And the calculator uses minors, and so it's fast because it's a computer, right? So to find z, I need to get my numerator determinant. So to get my numerator determinant, I'm going to replace the final column with the right-hand side. And then I'm going to use my quote unquote wraparound process to do this computation. All right, so I'm going to go down and to the right again. Unfortunately, when you're dealing with matrices, oftentimes there's not an easy way to do problems. They just matrices are the simplest for dealing with complex situations. Matrices and determinants of matrices are one or the other are the simplest ways to deal with complicated situations. All right, so the first one here is -4. Okay, the next one is -9. And the last one for the down and to the right is 1. Add those up. I think that's -12. Let me write it over here. It's -12. And then I'm going to add, subtract my down and to the left product. So I'm going to go down and to the left now. Okay, we'll do the first one there, which is 6. Okay. Plus the next one, 1 times 1 times 1. 1. And finally, the last one is +6, I believe. 1 times -2 times -3 is +6. Okay, so what is that? That is -12 minus 13. -25. I think that's +5/2. If you are ever doing calculating solutions to large systems by hand, I highly, highly recommend you check your answer with something else because it's very easy to make mistakes. Now, on a test, you don't have an option for test, for checking your work. But if you're, dealing with practice, doing practice, you can use things like MATLAB or Wolfram Alpha or Mathematica. So let's just type this in the Wolfram Alpha here and see what we get. Just have to type the 3 equations in. Okay, and let's see if give us our solution here. Okay, doesn't like systems, so let's just say solve. I'm a little surprised here because normally Wolfram Alpha will, let's go back to the original. Okay, there we go. So for some reason in the other mode, it did not like what I was doing. So x equal 1, y equal 1/2, and oh, I did not correctly okay, it looks like I've got a mistake here somewhere. Let's make sure my system is correct. 2x plus y minus z equal 1, x minus 2y plus 2z is equal to 3. Negative 3x plus y plus z is negative 1. All looks good. Okay, something is wrong here. All right, let's just take a closer look here. Down and to the right, we've got, let's make sure I've copied my matrix down correctly to 1. Okay, that's going to replace with 1, 1, negative 2, 3, negative 3, 1. Oh, right here. There's the problem. That should be negative 1 because of the right-hand side. So this should be a negative 1 right here. And therefore, this should be negative 1. So there's my mistake. That's why it's a good idea to be careful and check your answers. So let's go down and to the right again. Let's see, down and to the right. We've got, let's see, 4. And down and to the right again, that's negative 9. And then plus 1. Add those up. Minus 4, I believe. And we want to go down and to the left. The first one is 6. The second one is negative 1. And the third one is 6. So let's see if we get it this time. Negative 4 minus 11. Six plus 6 is 12. 12 minus 1 is 11. Oh, wait. It's 15, minus 15. There we go. I was doing my arithmetic wrong. So minus 15, which gives us 3/2. Right. So took us a few minutes there to get that one, but that's the idea. Okay, you got to be careful. Okay, so with that in mind, that's all we're going to have time for today. So what I will do is next time we meet, next Friday, we will begin by doing another one of these. So we'll talk about systems of 3 equations, 3 unknowns. We're going to do another example of one of these next Friday. If you have any questions, I'll be available for a couple of more minutes, and then we're going to close the webcast. Otherwise, have a good weekend. And remember, if you didn't get a chance to watch the first 20 minutes of the lecture today because you weren't here or you were unavailable, please look for the recording later this evening on ideas because there was some important information on there about how to pick up your midterm exam. Okay? All right. Otherwise, have a good day, have a good weekend, and I will see you next week. Okay, I do not see any questions, so I'm going to end the recording and the webcast.